Hi, this is Craig Stocks here at Utah Desert Remote Observatories. You can find us online at utahdesertremote.com. And this is kind of the third video in the series, and here we're going to start talking about managing color in narrowband images. So just to review very quickly, in the previous video we talked about RGB color and different ways to get natural color image through either an auto white balance or through something like SPCC, spectrophotometric color calibration. This video is going to focus more on narrowband images. So in an RGB image, it's pretty straightforward. We have images through a red filter, a green filter, and a blue filter, and we can apply color to each one of those. So we have red applied to red, green to green, blue to blue, and when you blend those together you get a more or less natural color image if the red, green, and blue brightnesses are individually balanced. In narrowband photography, we lose that ability to kind of stay grounded in some form of reality. I don't want to use the term scientifically correct because as soon as you start stretching your data, you've pretty much thrown out any true scientific value. Any true scientific analysis would need to be done from raw data. And certainly when you stretch narrowband images, you're losing any correlation to reality in one way, but you're trying to represent a different kind of reality. And maybe that'll become more obvious as we go through this. But as you know, gases become excited or ionized, and when that happens, they emit light. They actually glow. And every different gas glows at a very specific color. Hydrogen, oxygen, and sulfur are the three most common in astrophotography. Each has a different color that it emits. So we can use colored filters to isolate those specific colors. Sulfur and hydrogen both emit a very deep red color. And as you can see in the little color bar here at the bottom, they're very close together. Sulfur is just slightly more red than hydrogen, but I mean it's just by a few nanometers of wavelength. It's very close to the same color. Hydrogen is way up here at the other end in this kind of blue-green spectrum. So we can do the same thing we just did with our red, green, and blue. We know that oxygen is cyan, hydrogen should be red, and sulfur should be red. So we can color each one of those the correct color according to the wavelength of light that we're capturing. And when we combine that into an image, we get a color image, and you might even argue that it's close to a true color image. The problem is it's not an informative image because we can't tell in all this red, we don't really know what's hydrogen and what's sulfur. So if we want to know more about what the nebula is made of and less about what it just might look like if we could actually see all these colors, we need to do something different. And what we do is translate the color. So instead of having sulfur and hydrogen both as the same color of red and oxygen as cyan, we translate the color. We want to keep hydrogen less red than sulfur, but we can translate it so that it's a lot less red than hydrogen. In fact, we can slide hydrogen all the way over to the green. And when we do that, we typically then also take the oxygen and translate it from cyan or blue-green all the way over to blue. So that gives us an opportunity for a more dynamic color balance and more dynamic color contrast in the image. So in this example now, instead of red, red, and cyan, we make sulfur red, hydrogen green, and oxygen blue. And when we put those together, you can see we get a much more dynamic image. And if we look at it up close, now we have a chance of seeing Where is there a predominance of sulfur? Well, that's down here at the bottom. Where is there a lot of hydrogen? Well, that tends to be here. Anywhere there's yellow and green, that's where hydrogen is most dominant. And the blue areas are the areas where oxygen is the most dominant. So it's a more interesting picture, and it's also more interesting in terms of telling us what the nebula is made of. One drawback of this is, other than trying to keep the background neutral, we don't have a color balance that we can point to and say, well, that's the right color balance and that's the wrong color balance. We're trying to find something that shows the target well, shows the different structures well, but it's still always going to be a translated color. Some people use the term false color. It will never be a true color image, and that's okay. So let's hop into PixInsight, and instead of looking at an RGB image, let's look at a narrowband image. So I'm going to close these, and let's open the wizard, narrowband data. And let's see, it's going to be on my D drive. Swap files. There we go. So let's look at just the sulfur, hydrogen, and oxygen. So we'll focus just on narrowband. We know we can do the RGB stars with no problem, just like we looked at with the lagoon. So here we'll focus on just the sulfur, hydrogen, and oxygen of the Wizard Nebula. And these, of course, are grayscale images, just like our red, green, and blue. And let me spread these out so we can see them all. Now, if you remember, when I use the screen transfer function as a preview, it's going to stretch each one of these to a uniform brightness, not necessarily to the stretch to the same amount. So if I look at sulfur, it's stretching the sulfur data to a uniform brightness. That's what we see. Stretching the oxygen to a uniform brightness. That's what we see. And hydrogen, stretching it to a uniform brightness. This is what we see. Now, if I combine these into an SHO image in PixInsight, it'll probably come out very green. And in fact, let's just do that to find out. And the reason for that is because there's probably a lot brighter information in the hydrogen than in the sulfur and the oxygen. In fact, let's just verify that. Let's open up the histogram transformation tool, and let's actually apply this stretch for hydrogen. So I'm going to focus on the hydrogen. I'm going to calculate the stretch parameters, and then drag this down to the histogram transformation tool, click the square, and that will apply this calculated stretch to the hydrogen. Just for fun, let's apply the same stretch to the sulfur and the oxygen. So I'll just, without changing anything else, I'll drag the triangles up to the oxygen and to the sulfur. What this is going to show us now is if we apply the same amount of stretch to each one of the images. In other words, it's going to be more or less the same brightness. So this is what the hydrogen looks like. Oxygen, you'll notice the background's a little bit darker. And sulfur's even darker yet. So what that's telling us is, in order to brighten especially the sulfur to the same overall brightness as the hydrogen, it had to stretch it more. It had to brighten it more to get it to kind of a uniform brightness between the sulfur, hydrogen, and oxygen. Usually if you combine these, we'll see that kind of nasty color cast. So let's just real quickly throw these into an SHO. My oxygen in here, and my hydrogen in green. So this will show us an SHO image, and as we expected, it's very green because of the predominance. We have a lot of hydrogen, we have a lot of oxygen, but not as much, and we have sulfur, but again, not nearly as much, so we get a green image. Most of the time, most people by convention don't like green, at least not very much green in an astronomical image, and certainly our background is green. It's just not a good color balance. So let's just throw this one away, and let's start over. So let's do a unique stretch for each one of them. We've already stretched the hydrogen, so let's go to our sulfur, and if I open up the screen transfer function, and if we let it do its own calculation, it comes up with a much brighter image. And again, now I'll use the histogram transformation, and we'll permanently stretch the sulfur. There we go. And let's do the same thing with the oxygen. There's its stretching parameters. We'll apply those. For some reason, the recording is bogging down my computer. So there's our oxygen, there's our sulfur. So now they're stretched uniformly. That should at least give us a neutral background. Let's combine these just to see what they look like. So again, we'll take our sulfur and we'll put it into the red channel. We'll put our oxygen into the blue channel and our hydrogen into the green channel. And now we get a much nicer looking image. We have essentially done an unlinked stretch. We've stretched each one to a uniform brightness. And one thing you'll notice, very typical with SHO images, if you combine them this way, is you get a lot of magenta around the stars. There is a tool to address that. If you go to Scripts, Utilities, Correct Magenta Stars, and generally you can just execute it with the defaults, it will correct that magenta around the stars. And so now we have neutral looking stars and a not terrible color balance just by stretching sulfur, hydrogen, and oxygen more or less uniformly. Some targets will fall into a pleasing color combination more easily than others. The wizard is one that gets you fairly close to start with. But let's talk about how we can take it a step further in Photoshop. So what I've done is process this wizard data into a starless set of data as well as the stars. And so now we're looking at it in Photoshop. Here are my layer groups for sulfur, and it's color mapped red. Oxygen is color mapped blue. Hydrogen is color mapped green. And then we have the stars, and I'm just going to leave those turned off so we can really see what's happening. This is a pretty decent color balance overall, but I feel like the sulfur is still getting lost. It's not dominant enough. The colors are kind of two-dimensional. We've got yellow and cyan, not a lot of blue, not a lot of red, so it's kind of a dull looking image. The background is pretty neutral, but overall it just doesn't have a lot of pop. So there's basically two ways of controlling the color in images like this, and I'm talking about kind of at a primary level of adjustment. You can always go to global adjustments and use tools like a color balance to adjust an overall color balance, as well as hue saturation. You can increase saturation. You can even rotate the hue value a little bit. Generally, though, you want to get the image better than it is before you start using global adjustments. In fact, I'm just going to turn this global adjustments layer group off because it's not doing anything. The first thing I like to do is look at each one of the sulfur, oxygen, and hydrogen and make sure we're using the full range of data in each one of those. And this is a little bit like an auto white balance. So I'll focus first on the sulfur, and I want to turn off this hue saturation adjustment layer that's giving it the red color so it's easier to see. And now if I look at my levels adjustment layer, I can see that I'm not clipping any blacks, but I'm coming pretty close. One trick you can use is hold down the alternate key on Windows or Option on Mac, and then when you slide this black slider, you'll start to see where you're clipping. And if you look towards the center, you can see I'm just starting to clip in this area. So I want to back off a little bit so I'm not clipping anything important. Around the edge, I'm not too worried about because that'll probably get cropped out. And if there's a few pixels here and there that are getting clipped, that's okay too. Then I'll do the same thing with whites, but I can also just inspect and see the tail going towards the whites in the histogram stops about here. And so I want to bring my white slider up to not quite where the data starts. Now I'm using the full range of tonal values from close to 0 to close to 255. And so that's our first step in color balancing. I'll turn the color back on, turn off that layer group, and we'll just do the same thing with oxygen and hydrogen. Again, I want to find the level where it starts clipping important stuff in the center and back off a little bit, and then move the whites slider to just short of where the data starts. Now we're using the full range of blues, and let's do the same thing with greens. Turn off the color, and again check for clipping with holding down the alternate or option key. And we're already pretty close to clipping those. And how close you are to clipping depends on how the stretch was done in PixInsight. If you're just using the default screen transfer function for the stretch, then you may have to adjust the sliders a little bit more, and that's perfectly fine. And that's one of the reasons I don't really get too worked up over how I do the stretch in PixInsight. My goal in PixInsight is to make sure I'm preserving the full range of tones so that nothing is clipped at black and nothing is clipped at white. So now if we turn on all three colors, you can see that we've got already a more vibrant color balance, a little bit more color saturation. We're starting to pick up more reds down here. I'd still like to get more reds in the image, and I would like to see these yellows be either yellow or green, but not this kind of orangey green that they currently are. So we have two basic ways of controlling the three colors. We've got sulfur, oxygen, and hydrogen, and right now they're mapped red, green, and blue. We have two options. We can either change the color that it's mapped, or we can change the intensity of that color. So if we want to change the intensity, and that's usually where you should start, I would typically start with the sulfur because it usually is the one that needs the most boost, and go to the levels adjustment layer in that sulfur layer group. And remember, sulfur is contributing red. So if I make the red layer group brighter, it's going to put more red into the image. Now I've already set the endpoint, so I don't want to move the whites slider, but I can move the midpoint slider all I want. So if I move it to the left, you can see it's bringing out more red in the background. But some of even the areas that should be black are starting, or neutral, are starting to turn red. So that's an indication I probably need to move this black slider back to the right a little bit. And sometimes this is a bit of an iterative process, but by just tweaking those reds and making them a little bit more intense, we can bring out more of that red in the background. And we're not adding sulfur that wasn't there, we're just allowing the sulfur to be more prominent than it would be otherwise, so that we can see what's going on. Now we can do the same thing with the oxygen. And of course the beauty of this in Photoshop is you're looking at the image live as you're making the adjustment. So there's no mystery of what color it's going to be. Same thing, let's put more blue in here. Background starting to get a little blue, so I'll take some of that away with the black slider. And that's giving us just overall a nicer yellow. We've got cyans and blues, reds. Let's go to the hydrogen. Hydrogen is almost always the strongest of the three, and it's the one that you want to have the least impact in terms of making things green. I'm not completely afraid of green. We've got some green showing up here, getting almost green up in here. So this really becomes a matter of what you think is appropriate. I do see some green in the background, so I'm going to darken the blacks in the hydrogen, and that's because we want to take green out of the dark areas. So by darkening the blacks in the greens group, that takes some of that green away. I can play with the overall brightness, and once we darken the blacks, adding a little bit more green in the midtones works okay. So now we have a much more vibrant image than we had to start with. Now I will go to my global adjustments. So let's just collapse these three. Let's turn on our global adjustments. One of the first things you may have noticed is some of these areas that were just kind of dark and noisy. This layer of RGB values of 19, 19, 19. So this is just a solid fill layer. That does a good job of kind of neutralizing anything that is darker than that and gives me a nice uniform background. I don't want it to have a lot of impact. It looks like I would say it's having too much impact in the center of the image. So that's an indication I probably need to lighten my image a little bit, which I'll do with my global levels adjustment, and I may even lighten the darks a little bit. I've got a lot of orange. A lot of my reds have become orange. So I'm going to address those with a hue saturation global adjustment now. Now I can target either the global saturation, but in this case I want to target just the reds, so I can choose the reds. If you have an older version of Photoshop, this will be a drop down rather than the buttons. And by targeting just the reds in the image, if I adjust the hue of those reds and move it to the left, that will make them more red. So now I'm bringing out even more red in the image. And then I might target my yellows and see if I want them to be even more yellow or a little bit of orange. And I think a little bit of orange, a little bit more red, less green works well for them. We might target the cyans and tease those a little bit towards the blue. We don't want to lose them altogether though. But you can see with those adjustments we still have a neutral background, but by maximizing the range of each one of the colors, that gives us a much better overall color balance, and we didn't have to change our individual colors. Sometimes it is useful to adjust individual colors, and to do that, let's look at the oxygen for instance. If I look at this hue saturation layer in the oxygen layer group, that is color mapping the oxygen to blue. And you can experiment with moving this hue slider a little bit left or right, and sometimes you'll find that just a little bit of a change to the hue in those narrowband layer groups can make a real difference in the overall color balance of the image. Now I'm just playing with the, if I slide this green just ever so slightly towards red, I feel like that gives me a better color balance. And by better color balance, I'm looking for attractive color, I'm looking for color balance. In other words, kind of equal amounts and equal saturations of the different colors, and good color contrast. In other words, good difference in color between different structures. So for instance, between the red and the yellow, or between the yellow and the cyan and the blue, so that they don't blend together visually. And starting to see more green coming in the background, so I'll probably, as a final adjustment, come back to my hydrogen and drop that black level a little bit more, just to take some of that green hydrogen out of the background. So there's a look at color balance. We looked at how you would do it with an RGB image. This one focused on narrowband images, and at the end of the day, we really did three things. We created narrowband sulfur, hydrogen, and oxygen layers that had uniform brightness overall, and then we adjusted the brightness range so that each one of those had a full representation of tones. Then we used the brightness of the red, green, and blue to adjust the red, green, and blue intensity in the image before going into some global adjustments to fine-tune the image. I hope you found this useful. If you have any questions, drop those in the comments down below. And as always, I hope you have a great day today and an even better night tonight under a clear, dark sky. Thanks.